Welcome to the next stage of today's lesson, where we are going to take everything that we have figured out and we are going to write it down into a table and then into a graph. So if you haven't done part 1 in this problem, which is annotating and counting the dots in step 0, step 1, step 2, step 3, step 4, and step 5, do that, or go back and look at the other video. And we are going to jump right into putting this into a table. So I am going to be flipping back and forth looking at these numbers and these numbers, but you should be following along in your own table. There we go. Okay. So first we need to make the table. You should be doing this on your own. I'm going to be doing it on the video. And if I finish before you do, pause the video and make sure that you're filling out the table before you move on. So, step this is pattern 1, number of dots, and pattern 2, number of dots. Okay, let me use my Oakland library card to draw in some lines here. Alright, step 0, step 1, step 2, step 3, step 4, step 5, oh, and it jumps to step 10, and then step N. Alright, at this point, I'm going to start filling in this pattern, the number of dots. You should do this on your own. Again, if you're not ready, pause the video, do this on your own, and then come back. One note, this last line here, this N, this is asking, can we find the rule for the pattern? And this one is the tricky one. So I'm going to save this one for last, but this is the one that I want to see if you can figure out on your own. What is the rule for this pattern? So if you want, pause the video to fill this out. I will be filling it out while you do. Okay. So number of dots in pattern 1 started with 1 dot. I'm looking at my notes on the other side. And then it went to, actually, I want to I don't want to put this in the middle yet. I'm going to put it off to the side. And then in the first step 1, there were 3 dots. And then 5, and 7, and 9, and 11. The jump from step 5 to step 10 is going to be more, and this N is going to be more as well. So I'm going to hold off on that. 0, step 1 was 1, 4, 9, 16, 25. Okay. So the directions don't say this, but we are going to do some annotating. So, and I'm going to do almost exactly the same style of annotating as we did on the patterns in the previous video. So in this one, in pattern 1, this 1 was just there all the time. But the 3 came from the 1 and then plus the 2 extra dots, right? Okay, we could say that the 5 came from the 3 plus the 2 extra dots, but I'm going to say it a little differently. I'm going to say that the 5 came from the 1, from this 1 but then we added 2 pairs of dots. 2 pairs of dots. Right. If you don't remember, go back and look at the other video. 2 pairs of dots. Which means this 7 said, let's take the 1 and add 3 pairs of dots. And you guys see what's going on here? The 9 says take the 1, but then we're going to line up 4 pairs of dots. And the 11 says take the 1 and add 5 pairs of dots. And here is the thing you have to connect. The number we see here, right, the number of pairs of dots, do you see that it's also the same thing as the step number, right? 2 pairs was step 2, 3 pairs in step 3, 4 pairs in step 4, 5 pairs in step 5. So if we look at step 10, I don't know what the number total is going to be yet, but I do know that to get it, we're going to start with the 1, and we're going to add 10 pairs of dots. And how many is that? So 10 times 2 is 20, plus 1 is 21. So I would expect this to be 21 dots if we did the whole thing. So what's the pattern? Well, the pattern seems to be to get whatever number you want here, you start with the 1 from step 0, and you add on however many pairs you want. So this step is saying if you have some step number, right? If it's a 10, you write a 10. If it's a 5, you write a 5. So for n, we write n times 2, right? Take the n, whatever that number is, that's the number of 2's you add, or that's the pairs you add. So this is our rule right here. This should remind you maybe in a slightly different order. Let me rewrite this. What if I wrote this in the order of 2n plus 1? It's the same thing, just switch the multiplication here and put the plus 1 in the back. But this should look really familiar. This, we're going to have thought bubbles and thought bubbles. This looks like y equals mx plus b, right? It looks like this format here, which we know is a linear pattern. Right, so this looks like a linear formula. Okay, pattern number 2 though. So pattern number 2, do you remember how we did this? So this was, well, this is just 0, right? But then this 1, we said this 1 came from looking at a 1 by 1 box. The 4 came from looking at a 2 by 2 box. The 9 came from looking at a 3 by 3 box. Square. Should I say square? I'll say square. Square. 16 came from looking at a 4 by 4 square. And 25 came from looking at a 5 by 5 square. Now, if that was too fast, go back and make sure you are looking at what we did and what we said in our light blue annotating for each step, right? Step 1, step 2, step 3, and I didn't put in the dots, but step 4 and 5 was a 4 by 4 and a 5 by 5. Right? Okay, so this table. So again, the trick is to realize how this multiplication seems to be corresponding to the step number. So in step 1, we did 1 times 1. In step 2, we did 2 times 2. In step 3, we did 3 times 3. In step 4, we did 4 times 4. Is this boring yet? In step 5, we did 5 times 5. So in step 10, we don't know what number we're going to get here. But what are we going to multiply together? Well, this should be 10 times 10, which is 100. So what's the rule? If I want to get to any step number, what rule do I need to follow? What do I need to do with that step number? Well, if 10 turns everything into 10 times 10, then n, this should be n times n. And that's it. There is another way to write this, right? When you do n times n, do you guys know this? If you multiply something by itself, this is the same thing as squared. So we could do all of these squared, etc., etc. Right? This is not a linear pattern. This is a new kind of formula. And we're going to be studying this formula a lot, so I don't mind just kind of like telling you that this formula, whenever you have something that's squared in it, we say that this is called quadratic. Quadratic. Right? And we are going to be studying this a lot. You're going to be hearing this word a lot, and that's the way it's going to be. All right. Plotting these dots. So plotting these dots is going to be pretty time consuming. And so I am going to say, if you want to plot these dots, you should either have graph paper, but if you don't have graph paper, you should probably just go into Desmos and just plot these out. I will do the plotting in this afternoon's live stream. Let's do it that way. I will do the plotting in the afternoon live stream. If you can't catch it live, then you can watch the recording of me doing that step. So this is the kind of question we're doing. What happens when you graph these points? So do this on your own, as to the best of your ability, and then if you're getting stuck looking at this, we will look at it together this afternoon. Okay guys, I'll see you in the next video. Bye bye.